Hello students, welcome to ACE Preparation League. Just see, today's our session is very interesting session. You can take the question of expected questions for GATE 2022 for ME as well as PI, for mechanical engineering as well as PI, that is production and industrial engineering. Now see, the two topics I am going to take here, one is casting and second is welding. Why to attend this session? Why to study this session? What are the reason for that? Yes, there are some important reasons, because first is you know that this is expected question. The second thing is that there are some common mistakes by student in the examination, and how to avoid that common mistake, that mistakes I will tell you here. Yes, now I hope you are ready for question number 1. Just see the first question here. Yeah. A sand core experiences. Just see, I am starting with metal casting. After metal casting, I will start with welding chapter. Let us start metal casting. Question number 1. A sand core experiences a buoyancy force of 17 kg. What is given here? Buoyancy force is given. I am writing buoyancy force. What is that force? 17 kg. Just see how important. Buoyancy force is always in Newton, but what are given here? Just see the wording, very important. You must be careful. A buoyancy force, force always in Newton, but what are written here? Kg. 17 kg, hence it is mass is given, not force is given. Hence, this is a 17 kg into multiply by 9.81. Yes, then you will go get buoyancy force. Yeah. Now see, what is the volume of sand core in millimeter cube? Concentrate on the unit. Volume of sand core. Volume of sand core we have to calculate, and that is denoted by capital V, that is volume in millimeter cube. The density of cast iron is 7.16 gram per centimeter cube. What is given? The density of cast iron means which molten metal we are using. Cast iron, molten metal we are using. Yes, then I am writing here density of M means molten metal of cast iron. Then I am writing is equal to 7.16 gram per centimeter cube. And the density of core is 1.8. Just see, density of core material is 1.8 gram per centimeter cube. Yes, what you have to calculate? You have to calculate the volume of sand core, that is capital V. Yeah, now see the important formula of this. Just see, I am writing the important formula here. You can reply, just I will solve. Yes, some equation, I will solve the question and I will see your reply. Yes, I will see your reply. The number of attendees are here, just, and some students are calculating also. Yeah, then you give the reply. Yes. Now see, net buoyant force. Net buoyant force BF, or we can also say net buoyancy force, is equal to weight of molten metal displaced. Weight of molten metal displaced. Yes, this is the weight of molten metal displaced minus weight of a core. Weight of core. What is the formula for weight? Rho g AH. I am writing here. What is the formula for weight? Rho g area into height. What is area into height? Area into height is volume. Then net buoyant force. What is the value of net buoyant force? You know that this value 17 into 9.81. I am writing that same 17 into 9.81. is equal to weight of molten metal displaced, that is rho GV of molten metal minus weight of core, again same weight formula rho GV of core. What term we can take it common? Just see the volume and G we can take it common, G into volume rho m minus rho c, and this is 17 into 9.81. Yes, now it is important. What is the unit of G, guys? But before that, just see in the examination, is the value of G is mentioned in the question? Just see, is the value of G is given? No, not given. If the value is not given, then G we can take 9.81 meter per second square. But sometime in the question they will mention that value, that is 10. If they mention, then only take that 10 meter per second square. If it is not mentioned, never take 10 meter per second square, only take 9.81 meter per second square. Hence, I am writing this value with the confidence. 17 into 9.81 is equal to, this G is also 9.81 into volume I have to calculate, into volume into density difference. Density difference is there. Now you need to concentrate on the unit. You know that what is G? Meter per second square. What are the densities are given? Just see. What are the units of density? Gram per centimeter cube. We need to convert that densities into kilogram per meter cube. Just multiply by 10 raised to 3, 7.16 into 10 raised to 3 kilogram per meter cube. And here is also same, 1.8 into 10 raised to 3 kilogram per meter cube. Yeah. Now put the value. This is into 10 raised to 3, that is 7160, and it is 1800. And you know that in the theory the density of core is what? 1800, 1900, 2000, means 1800 to 2200 kilogram per meter cube. Here it is also 1800 kilogram per meter cube. Just see. Yeah, 7160 minus 1800. Yeah, now you will get volume. Just calculate the volume. What the answer of volume you will get? Some student gave me that answer. Yes, Pradhan, given that 3.17. Someone is giving that 3171.64. Yes, now you can see that. What is the answer you are getting here? What is the answer of volume here? 3.17. Just calculate it and give me answer. 3.17 into 10 raised to minus 3 meter cube. Yes, but what they said? They said that give the answer in millimeter cube. Give the answer in millimeter cube. Now we need to convert that. You know that is 1 meter is equal to 1000 millimeter. Yes, you need to convert. Yes, then I am writing here 1 meter cube is equal to, or simply just I can write 1 meter is equal to 10 raised to 3 millimeter. Then meter cube is equal to 10 raised to 9 millimeter cube. Then what is the answer here? Yes, there are some common mistakes. Just give me answer. Fadafat, I am waiting for your answer. Then the final answer for volume is 3.17 into 10 raised to 6 millimeter cube. Why some student did the mistake? The reason behind that, they didn't read this problem carefully. Here it is given the volume of sand core in millimeter cube. Now I am waiting for your answer. Is this answer is right? Just solve it and tell me. I am waiting for your answer. Yes. Yeah, students are giving, very good, very good. Vinayak, very good, very nice, solid fast. That is why I said you that this lecture is very important. There is a game of units, you need to be careful, you need to read the problem carefully. You know that, you know the formula, you have the knowledge, you have everything, but you must be careful about units, what I have written in question. Very good, many students are calculating. Yes, I am waiting for your reply, fast. Yes, Ajinkya also calculated, correct answer. Yes, Maranika also calculated, very good, very good. I think you got that. How's the common mistake are there? Initially students started giving answer very fastly without thinking about the unit. What about this millimeter cube, this kg, all the things are here. Yes, I think you are happy with this question, and you have to see such a number of question here. And at the end of lecture, I know that many students have my mobile number, but at the end of lecture I will provide my mobile number. You can ask your queries on WhatsApp, right, on my WhatsApp. Right. Now we can, I think it is enough time for this question, and now we need to move for next question. Yes, Funny is also calculated. Yeah, many students are calculated, very nice response. You can put this video on your WhatsApp status also or Insta also, then your friends also can watch this video. Yeah, now see the same type of question, little bit tricky, you need to solve, don't do mistake. Yes, now see, in a sand casting operation, a mold having dimension of 150 by 100 by 50 all in millimeter is filled with the molten metal through a gate with height h and cross sectional area a. Mold filling time is T1. Very nice question, one of the top class question. See, I am writing the given data. What is this? This is the sand casting operation. This is one of the operation, and you can see that the dimensions of mold is given. Mold is given means dimension of casting cavity is given. Am I right? Dimensions of the casting cavity is given, and that casting cavity we have to fill by molten metal. Right? Now see, we are filling. How we are filling? For filling of that molten metal into casting cavity, you can see the height h. What is given? Through a gate with a height h. Then I am writing here h. Cross sectional area A. And then what is filling time is T1. This is the first case. This is our one of the method. But now means just see, if you are in industry and you are solving the number of questions, number of practical application, number of casting product you are producing by this dimension. But now you are engineer, you went to that company, you joined that company, now you want some changes. You want some changes. That's why what is the case? What you are doing the changes? Just see, the height is now doubled. You did that changes. What you think that? Just see, the height is now doubled. Initially height was h1, cross sectional area was a1, this is t1. T1 means what? Filling time, and that is also known as pouring time. Right, it is a T1, and now height is now doubled. You want double height. Yes, height means that sprue height, right? You want double height. Then I am writing S2 is double of H1. Then I am writing here 2 times of H1. Right, yeah. The cross sectional area is half. Cross sectional area half. Half cross sectional area means A2 for second casting you are taking half a cross section area, that is 1 by 2, 0.5 A1, 0.5 A1, and the corresponding filling time means pouring time is T2. T2, yes, what we have to calculate? the ratio of T2 by T1. Ratio of T2 by T1 you have to calculate. How to calculate? Very easy. Many students are there, even though they are solving, and what record break performance. I am giving the wonderful question, but my students are solving and they are giving the answer now very fast. That is the revision lecture. This is the revision lecture. This is the expected question. Very important lecture. I got answer before solving the question. How performance? Just see. Yes. Now, firstly, I want to write the formula for filling time. Filling time is also known as powering time. What is that powering time? That is volume divided by area into velocity. Some people can say minimum area into maximum velocity. No problem, we can say. Yeah. Now, we need the ratio of T2 by T1. Ratio of T2 by T1, then I am writing here T2 by T1. T2 is powering time 2 divided by PT1 is powering time 1. What is the formula of powering time? Just see volume. I am writing for 2. I am writing for 2. Then just see volume divided by area into velocity for second condition divided by, here I am writing this PT1, that is volume divided by area into velocity. I am writing here for first. Yes. Now see, just see the dimension of volume, that is 150 into 100 into 50, multiply that, you will get volume. The volume for case 1, volume for case 2 remains same. Yes, and that is why just see, cut that volume with confidence. Yes. Yeah. Now I am writing, just see. This is A1 V1 by A2 V2. What is A1? Just I am writing A1. What is V1? V1. What is A2? 0.5 A1 into what is V2? Just see. V2 is, just see, I am doing some changes here. I am not directly writing the V1. I want to write the formula for that. Just see, I am writing the formula. V1, what is the formula for velocity? It is a 2g h1. And here also I am writing 2g h2. Why this? Why h1 h2? Because here you can see the relation of h1 h2 is given. Here we have to put the A2 is 0.5 A1. We kept it that h2 is equal to 2 h1. We have to put it there. Yes. Now see, this is cancelled. This 2g will get cancelled. Very nice. Is equal to, you can see, in the root h1 divided by 0.5 root of h2. h2 is 2 times of h1. Now this h1 get cancelled. Then what is the remaining? Remaining is 1 by 0.5 under root of 2. Yes, till now I got many answers. Yes, very good. Vinayak, Ajinkya, very good. Very good. Very nice. Then that answer is 1.41 is the exact answer. Yes. Definitely you like this question. Yeah. But questions are little bit difficult. But again you see some question, you will feel interest, and you will be happy at the end of this session. Now see the next question. Yeah. A casting of a casting of 300 millimeter by 200 millimeter by 50 millimeter size is to be cast without any riser. No, don't use riser. The height of cope is 450 millimeter. Height of cope is 450 millimeter and height of metal during pouring is 100 millimeter. Not easy question. Just see. Just see in this diagram. This is the cope. I said you, this is the cope, and you can see this is the basin. Yes, you can see that. Yes, what is the dimension of cope is given 450, because this is the cope, upper portion is cope, lower portion is drag, and what is the height of powering above the cope is 100 millimeter. Just see both the dimension 450 100 millimeter. Now tell me what is the total height of powering. I am writing the total height of powering, that is 450 plus of 100 is equal to 550 millimeter. Don't forget the unit, just see here 450 100, yes 550. Now see next. Now also it is important, the gating ratio given as 2:1:1. Just see what is the gating ratio. Area of a sprue as to area of runner as to area of in-gate is equal to 2:1:1. Sprue is bigger is given. But what is the important case? Listen carefully. Minimum area we have to take. We need to take choke area. AC. I am writing here. AC is the choke area. That is A minimum is area. What is that A minimum? Just see the minimum of area of a sprue, comma area of runner, comma area of in-gate. In most of the example, you will get that area of a sprue is minimum, but this is not this case. In this case, the area of sprue is bigger and it is possible. It is possible, and area of runner and in-gate, just you can see 1:1, 1:1 means it is same. Right. Now, is the dimension is given? Yes. In-gate area is 50 millimeter square, means area, minimum area is what? Area of in-gate, which we have to use, and I am using it. Area of in-gate is 50 millimeter square, and the cross sectional area of the horizontal runner is also 50 millimeter square. Yeah, you can see that here 1:2:1:1. This is runner, in-gate, no problem. In-gate area is equal to runner area, that we have to consider here. Assuming no losses, the time required to fill a mold cavity of volume 10⁶ millimeter cube, what we have to calculate? We have to calculate the powering time is required. Just see, these questions are also students solving with very interest. Just I am looking at the answer, really you are taking interest. Yes, what we have to calculate? We have to calculate the powering time, and what is the volume is equal to 10⁶ millimeter cube. Yes, now see how to solve. Just I am putting the formula of powering time here, very easy. Powering time is equal to volume divided by area into velocity. Then what is volume here? Volume is 10⁶ divided by area. Just see the minimum area we have to take. Minimum area, that is area of in-gate, area of runner, we can take 50 millimeter square. I am writing here 50 millimeter square into velocity is into 2gh. Here h is total. Now this is a common mistake. What the student did? What the student, they are writing, they are simply writing here that 450 height of cope they are writing, but it is not the 450, 450 plus 100. That is why this question is important. You may go wrong. Yes, that is why you see here I am writing, just see it is 10⁶ divided by 50 into 2. What about G? Some students are just see the G is given. Just see, don't take 9.81, otherwise you will give me a wrong answer. Just given is 10. Just use that 10. But what is given? Meter. You can see all our dimensions are in millimeter. Convert into millimeter. G 9.81 meter per, sorry, just see, just see, 10. I am also doing mistake. Yes, in the examination you may also do. Please careful, but I got no, I am writing something wrong. Here you can see 10 meter convert into millimeter, that is 10 into 10 raised to 3 into what is height total? Height total is 550. Now I want your answer. Now I want your answer. Yes. Just see, I did here one mistake. By mistake, I return. Please wait. Something happened here. Please wait. Yes, this diagram is also here. Yeah, everything is right. Just tick volume. I need to write 300, 250. Yes, by mistake, I written 10 raised to 6. Yes, just see once again that volume 300, 200 by 50, and now solve. And now give the answer. Just solve it. Just solve it fast. Yes, tell me what is the answer. Yes, 18.09. Very good. This is in second. Yes. Yeah, now we can move for the next question, but before that I want to tell you that I am facing little bit cough, you may get disturbed. Yes. Yeah. Now see the next question. I think everyone saw I got replies. Yes, I can. Yes, one student raised a question that is very good question. This is by mistake, assuming no losses. Just see the question, assuming no losses, the time required to fill mold cavity. That question is enough. There is no need of this one. Yeah, and from that we got that answer, that is 18.09 seconds. Is this clear now? By mistake I written there. Yes, is this clear? Everyone please reply me. Yeah, now move for the next question. Yes, some student raised some question here. Please, at the end of session I will give my phone number, you can contact. Some student didn't attended my lectures, then they may face some difficulty here. Then you can message me on WhatsApp, I will give you number, don't call directly, just give message on WhatsApp, I will reply you. Yes, no problem. We can move for the next question. Very nice response from you. Yeah. Now see the next question. A cylindrical riser must be designed for a sand casting mold. The casting is a steel rectangular plate with a dimension of 12.5 centimeter, 7.5 centimeter, 2 centimeter. Yes, I want to read it again. There is one cylindrical riser which we need to design. Yes, just see, to design anything means what? Cylindrical riser design means design the riser dimension, design the knuckle joint, machine design the quarter joint, design the shaft means what? Design the dimensions of that component. Design of shaft means calculate the diameter. Yes, in this case a cylindrical riser must be designed means we have to calculate the dimensions of riser. For a sand casting mold, the casting of steel of rectangular plate, just see the casting size is given, means I can write here the volume of casting is given. Volume of casting is given, that I am writing here 12.5 into 7.5 into 2. Yes, previous observation have indicated that the total solidification time for this casting, yes, solidification time of this casting is 1.6 minute. Then I am writing solidification time of casting is 1.6 minute. Yes, determine the diameter of riser. I am writing here determine the diameter of riser. This is, I can write D or diameter of riser, so that its solidification time is 2 minutes. Just see, solidification time of riser is 2 minutes. 2 minutes. Yes. Now also listen that, listen carefully. Just see the theory concept here. Then we will design the diameter of riser. You can see that the solidification time of casting is 1.6 minutes. Means you can see that if it is a casting, just see if it is a casting, just you can see a simple diagram I am drawing here, and here you can see if this is the riser, this is the riser, and this is the casting. Just see what is the solidification time of casting, 1.6 minutes. You know that casting will solidify earlier, after then whatever the molten metal present in riser will solidify. Means first the molten metal in the casting must solidify, after that molten metal in the riser can solidify. Means if the casting is going to solidifying, its volume decreases and the riser can supply the molten metal to the casting. Hence riser, whatever the molten metal present in the riser must solidify later, then and then it can supply molten metal. Yes, same you can see. The problem is also saying same, that solid casting will solidify earlier, after that casting the riser will solidify, right? Yeah. Now we have to solve this question, but before that I want to see your replies. Yes, very nice responses here, very nice. And I will also give you one of the best questions I will give in this lecture. Very good. Yeah. Now see how to solve this question, very easy. Yeah, now see, solidification time of riser divided by solidification of time of casting is equal to modulus of riser divided by modulus of casting whole square. This is the formula. From where it come from here, solidification time is K into tau square. Solidification time is equal to K into not tau square here, K into m square. From where? From here this formula comes. Yeah, this is the formula. Then you know that solidification time of riser is 2, solidification time of casting is 1.6, is equal to what is the modulus of riser? Just see what is the modulus of riser. Just see here, determine the diameter of riser so that its solidification time is 2 minutes. Riser, listen carefully, maybe the top riser, riser may be the side riser, riser may be the spherical riser, but modulus of riser is always same. that modulus of riser I am writing that is d by 6. The same I am writing the modulus of riser is d by 6, no need to worry whether it is top, side or spherical, no need to worry. Is the mentioned, is it is mentioned in the question which type of riser is there? No. Is this written? They may written that, just see, you checked it, no need to worry. Yeah, the formula is fixed, yeah, this is over. Now see next, that is a modulus of casting. Now we have to calculate. Yeah, some student given answer already and that answer is correct. Yes. Now see how to calculate that modulus of casting. Yeah, what is modulus? Volume divided by surface area. Now see the dimensions here. Yeah, these dimension I have to put 12.5, 7.5 into 2. Divided by surface area 2 into this plus this into this plus 12.5 into 2. Yes. And now the answer of modulus of casting is 0.70. Put it here. What is modulus of riser? D by 6 into what is modulus of casting? 0.70 square. Calculate diameter of riser. And many students calculated that with the confidence and they gave the diameter answer is 4.7. What is the unit? Everything is in centimeter. Then unit of diameter must be in centimeter. You can see these volumes, everything is in centimeter, then this answer is also in centimeter. Yes, just I want to see your wonderful replies. Yes, Bittu Kumar, Surya, very good. I want again reply. I want more reply here. Aspirant. I don't know actual name. Very good. Yes. Now the next problem is very interesting problem and you will enjoy this problem. Just see. Yes, a casting of size. Just see the casting size is given, that is volume of casting is given. 120 millimeter, 80 millimeter, 40 millimeter is required. Assume shrinkage volume of a casting as a 5%. Design side riser. Design side riser. Yeah. Now this problem is little bit critical. If you are comparing with the last problem, this problem is somewhat difficult. Nothing is mentioned about the solidification time. Nothing. In the last problem there was a solidification time, here nothing. How to solve this question? Yeah, there is a very interesting topic in the casting chapter that is known as riser design. That is known as riser design, and the most important is methods of riser design, and in that methods of riser design you can see that most of the important is shrinkage volume consideration methods. This is the most important method. Shrinkage volume consideration. How to identify? Just see, you have to identify whether this problem on Keynes method, modulus method, novel research method or shrinkage volume consideration method. Firstly, you have to identify. Now, just see this question. If the percentage of shrinkage is given, then this is the question of shrinkage volume consideration method, that is fourth method. Just shrinkage volume is given 5%, then this fourth one method we have to consider. Here I do not want to speak in detail on that. Yeah, now see. Yeah, then that method we are going with that method. Yeah. shrinkage volume of casting as 5%. Firstly, I am writing here, it is also given side riser. I am writing for side riser, for a side riser, we can write down D is equal to H. This is for side riser. Yes. Now see next, what is given? Shrinkage volume is given, but before that I want to write that volume of riser must be greater than equal to 3 times shrinkage volume. Shrinkage volume is we are pouring the molten metal into casting cavity. Yes, then what happened? The shrinkage of that molten metal is started. Shrinkage, reduction in volume is starting. Yes, that is the shrinkage volume. How much volume is shrinkage? Means if we pour 100 millimeter cube of molten metal, now the remaining molten metal is only 90 millimeter cube, then what is the shrinkage? Just see the difference. 10 millimeter cube is the shrinkage, then this is the shrinkage volume. Yes, this and this criteria must satisfy. Then riser volume means whatever the molten metal present in the riser must be greater than or equal to 3 times shrinkage volume. This is the criteria here, but in the examination sometime they can also mention instead of 3, 4, 5, 6. But if nothing is mentioned, then you have to take riser volume is greater than or equal to 3 times shrinkage volume. Yes, this is the question. Yeah. Now see, I am solving here. Firstly, I want to calculate here. Yes, many students are replying here. Many students are replying here. Very nice performance, really very nice performance. But I want to solve it here first. Just see, I am writing here. What is the formula for volume of riser? It is pi by 4 d square h. Because it is side riser. This is the formula. But for side riser, you can see d is equal to h. Then instead of H we can put here D, no problem. Then now I am writing shrinkage volume, that is VSC. What is shrinkage volume? The formula is A divided by 100 into volume of casting. What is A? What is A here? You can see A is a 5%. Then 5% means 5 divided by 100 into volume of casting. Just put this value. Volume of casting is this one, 120, 80, 40. Yes, yeah, and now solved it. VSC. What is the answer of VSC? My student already calculated final answer. They don't know that answer. They already given the final answer only. This is the shrinkage volume. Yes. Now I am putting here riser volume, that is pi by 4 d square h must be greater than or equal to 3 times this value I am putting. Yes. Pi by 4 d square h must be greater than equal to 3 times, what is our value? 9200. That is the value. Yes, that we have to put. And then again we can write pi by 4. What is h? H is d. Then we can write here d cube. Then we can write is equal to 3 into 19200. And from that you will get the answer of diameter. Tell me what is the answer of the diameter? Yes, some student given that, some Surya given that 41.85, 41.85 millimeter. But this is the shrinkage volume consideration method. This diameter we need to check whether this diameter is correct or wrong. We need to check it, and for the checking you need to see the case 1. This is most interesting method and most difficult method and most important method. Just see what is the case 1. Case 1 is saying that solidification time of riser must be greater than equal to solidification time of casting. But we know that the formula of solidification tau is directly proportional to ms square. Then here we can write mrs square must be greater than or equal to mc square. Then also we can write it here mr must be greater than or equal to mc. Yes. Then what is the modulus of riser? That is, you know that the whether it is top riser, whether it is side riser, the volume is d by 6. Then I am writing here with confidence d by 6 must be greater than or equal to modulus of casting. Modulus of casting. Now we need to calculate that modulus of casting. What is the formula of modulus of casting? Modulus of casting is volume divided by surface area. What is the volume of casting? Just see our casting dimensions here, 120, 80, 40, that we have to calculate. Yes, volume 120 into 80 into 40. Yes, divided by 2 into 2 into 120 into 80 plus of 80 into 40 plus of 120 into 40. Yes, and solve it. Yes, you will get this value modulus of casting. Is anyone calculated that modulus of casting? No, student directly calculated the diameter, that modulus of casting is 10.9. Then I am writing d by 6 must be greater than or equal to 10.9. Yes, this is. Now what is the d? We have the value of d. We calculated that d initially. What is that d? 41.85. Then 41.85 divided by 6 must be greater than or equal to 10.9. No, this answer is around 7. 7 must be greater than or equal to 10.9. No, case 1 is not satisfying. It must satisfy. Then we can't take this diameter 41.86. You can see that here we got the diameter 41.85. Now this is not a final diameter. That is the shrinkage volume consideration method. Not easy. Now see, if the case 1 is not satisfying, we need to go with case 2. What the case 2 is saying? Case 2 is again saying, case 2. What is the case 2? Just in the case 2, we can write down. Just I want to see some answer first. Give me answer first. Give me answer first. Yes, 10.9. One student gave answer. Actually, I get little bit late reply here. Yes. Give me answer first. One student gave, aspirant 65.45. Darshan Jadhav is also gave very early. Ajinkya is also given. Bittu Kumar is also given. What a Jabardast performance. Yeah. Now see, the solidification time of riser must be equal to solidification time of casting. We are writing, then it is modulus of riser square is equal to modulus of casting square. Then we can write it is modulus of riser is equal to modulus of casting. Then you know that the modulus of riser is d by 6 and modulus of casting is 10.9. Then instead of this d, already we have the d. Here we can write here it is as a d dash. Then what is the d dash? D dash is 10.9 into 6 and answer is 65.45. 65.45. Yes, this question is over. One of the best question, one of the difficult to understand, but I think you got it. But this is the question solving session. I need to solve little bit faster. Yes, I have some limitation, but whatever I tried here to teach very nicely. Yes, now it is, what is the time now? Now the time is already exceed. Yes, time is already exceed. The time is, that's why I want to take a break now. Yes, now this is the time for break. After that we will see one of the casting question important, then we can start for the welding. Now take the break of 5 minutes. Take the Now see the most important question, that is this question number 6, and many students are asking the question about the grey cast iron, about the grey cast iron. They have confusion and continuously they are asking me a question, and that is very important question. Now see what is the question given. The grey cast iron block 400 by 200 by 20 are to be cast in a sand mold, means we have to made the block of grey cast iron. Yes, grey cast iron block, grey cast iron casting we have to made. Then I want to write here the volume of casting. This is the volume of casting, are to be cast in a sand mold. Shrinkage allowance for pattern making is 2%. Shrinkage allowance is given, that is 2%. The ratio of volume of pattern, we have to calculate ratio. We have to calculate ratio volume of pattern to that of casting. Means I can write here volume of pattern to that of volume of casting. Volume of casting. Yes, that we have to calculate. This question is very easy. I want to say it is easiest, but still there are some confusion, and for that I need to solve it here. Yes, I want to remove your confusion before your examination, and definitely you can rock in your exam, and this session is useful for that only. How to avoid mistake and which type of question can come in the examination. Yes, now see this problem we have to solve. But before that, just see what is the shrinkage allowance. What is given? Shrinkage allowance of pattern is a 2%. We need to see shrinkage allowance first. What is shrinkage allowance? For that I put here one diagram. Just see on the diagram, you can see that the time is on x-axis. You can see that the temperature is on y-axis. The time and temperatures are given. And this diagram is cooling curve for a pure metal during casting. Pure metal. Yes, and in the most of the cases this graph is same. Conditions are different, but it will show like this only. But if the material changes, there are slightly changes in that graph also. Yes, in that graph there are 3 stages of cooling. This is the first stage of cooling, this is the second stage of cooling, and this is third stage of cooling. In the first stage, you can see this temperature. What is this temperature? That is powering temperature. Powering temperature means if you are taking the example of iron, then iron melting point temperature of iron is 1539 degrees centigrade. But we are powering the iron at a 1700 degrees centigrade, and this is 1700 degrees centigrade temperature. But in the question what is given? The grey cast iron, but just I said you what is the powering temperature. But here is the case of grey cast iron, right? Then in stage 1, stage 2 are there, just see. Here at the pouring temperature means metal is in liquid state. At here I can write A point, here I can write B point, here I can write C point, here I can write D point. A to B stage 1, in the stage 1 the metal is in liquid state. This at B point, this is a freezing temperature or melting point temperature also I can write for this point to this point. Here what is happening from B to C point? At B the material is at liquid state, but from B to C it will change to solid. At a point C it will convert into solid. But whatever the shrinkage, just see, listen carefully, actually I am not speaking in detail here, but A to B, B to C are there. In the A to B there is a shrinkage, B to C there is also shrinkage, and that shrinkage is known as liquid shrinkage, LS. Yes, at the C point we are breaking the mold and we are taking out the casted component, and from C to D what is happening? At a C point it is at solid condition. That liquid is converted into solid at C point. We are breaking the mold, taking out casting cavity, and C to D what is happening, that is stage 3, is outside the mold. C to D is outside the mold, and here also shrinkage is carrying, because at a C point if the temperature is melting point temperature, temperature is high temperature. If we are taking the iron, temperature is high 1539, but still it is in solid state. Your question may be there, sir, why at 1539 it is liquid and why at same 1539 it is solid. Just I do not want to discuss here. You can ask me on WhatsApp if you do not know. If you learn from me, then you know that. Yes, it is a sensible heat, latent heat concept is there. Here is a sensible heat loss, here is a latent heat loss, again here is a sensible heat loss. That concept is there. Yes, but why I am telling this theory here? Because this theory is important for your examination as well as the question which I showed you. For both purpose it is important. Yeah, stage 1, stage 2 is known as liquid shrinkage because the volume of liquid is going to reduce, but at C point that liquid is totally converted into solid. Hence from C to D what is happening? The volume of solid is going to decrease. Hence it is known as solid shrinkage. Hence it is known as solid shrinkage. Hence it is also known as shrinkage allowance. It is what? Solid shrinkage. Solid shrinkage, and that solid shrinkage is also known as shrinkage allowance. Then what is given in the question? In the question they given that what is given? Shrinkage allowance is given. To complete this problem we need the knowledge of theory. Yes, shrinkage allowance is given, means what they given? The solid shrinkage is given from C to D, means at the stage 3 the volume of the grey cast iron is reduces. But in the case of grey cast iron, from A to C, in most of the materials, now listen carefully, yeah, now listen carefully. Just I want to see your comments also here, what you are saying. Yes, you are all here and solved very nicely. I got many answer, very nice performance, really great. Huh? Yeah, now see. In the case of grey cast iron from A to C, what is happening means stage 1 and stage 2, what is happening? The shrinkage means reduction of volume of molten metal is not there, it is going to expand. It is going to expand. And what is happening from C to D? It will not expand while cooling. Want to repeat, while cooling from point A to point C, the grey cast iron will not contract, will expand. But from C to D means in stage 3 it behave like normal material, means from C to D it will contract only. And there is a very big concept, need 2 to 3 hours to teach that, and from that I am solving the question and just see what is the question. Yeah, here I want to solve, here I need to add 2% of shrinkage allowance. Because why I am adding the 2%? Because in the stage 3 there is a contraction, that is why I need to add. I do not want to speak in detailed manner, just see I am solving this question. Ratio is equal to volume of pattern. Now you can see that 2% we have to add everywhere to this volume. Then I am adding here 400 into, now you can see that how to solve that. 400 into 2% means into 1.02 into, just see the volume we are taking, the volume of pattern. Now see, if the volume of casting is like this, then volume of pattern must be bigger. Volume of pattern must be bigger in the case of grey cast iron. Then 400 into 1.02, then next 200 into 1.02 into 20 into 1.02, yeah, divided by volume of casting, that is same 400 into 200 into 20. Yes, then you can see this get cancelled, this get cancelled. Now what is answer? 1.02 cube, then answer is 1.06. I know that The student who have already idea of this question, but they are facing difficulties in the grey cast iron question, then their difficulties is solved already. But if the student is new here, he didn't learn from me, he didn't learn here, then it is very difficult for him to clear this question here. But whatever I solved, in that way you can go and you can solve. Now give responses, how are you feeling here? Yes. Ashutosh also gave answer, very good. Yeah, now we need to move. But before that, just I want to tell you that what important theory is here for casting chapter, important theory for casting. Yes, means which theory point is important for this GATE 2022? Most important is casting defect. Most important is casting defect. This casting defect, IIT Kharagpur like that casting defect, hence it is very important casting defect. After then special casting processes theory is also important. Special casting process. And then types of pattern is also important. Types of pattern. Yes, these three important theory which IIT Kharagpur likes. Now see the time, what is the time, and now we have less time and we need to move for the welding questions, right? Yeah. Now see the question on welding. Now again I am feeling very nice to start the welding questions. Few questions are there, but very nice questions. Yeah, now I am starting with the question 1. Now I am starting with the question 1, and top chat, live chat, number of students are there. Very good response I am getting from the student. Yes, and in the welding chapter also you gave the same response as you given in the casting. Now just solve this first question of welding. Try to solve. Yes. Yes, the question 1, the voltage arc length characteristic of power source is, the voltage arc length characteristic of power source is given, that is voltage is equal to 50 plus 20 L, 50 plus 20 L, where V is operating voltage in volt and what is L? L is the arc length. Subse important, very important, you can see that arc length must be in centimeter. Arc length is given in centimeter. Keep in mind that. Read the question carefully in examination. Again and again I am telling, and just see, if sometime you think that in your exam the question is very easy, don't solve it confidence. Read the data in the question and solve carefully. In the simple question also they can do something, they can change, and because of that change you can lose the mark. They are very talented people. Yeah, we need to careful. Even though easy question are there, don't be relaxed. Solve it carefully and the get marks and take the mark in your pocket. Right? Now see, this is given, just see the length is in centimeter. The open circuit voltage and short circuit current for arc length ranging from 2 to 3 millimeter. Just see, arc length is given 2 to 3 millimeter. Here what is given? Millimeter. Here what they are saying, V is equal to 50 plus 20 L, it is in centimeter. They must given in centimeter, but they written in millimeter. Then what to do? Just see 2 to 3, I am writing L1. I am converting into centimeter. You know that 1 centimeter is 10 millimeter. Then 1 millimeter is 10 raised to minus 1 centimeter. Then it is 0.2 centimeter. L1, L2 is 0.3 centimeter. And the current from 300 to 500 ampere during welding operation are. What we have to calculate? We have to calculate open circuit voltage and short circuit current we have to calculate. Open circuit voltage and short circuit current we have to calculate. This data is given, But my question is, why I written L1 here, why not L2? Just see carefully, yeah? Just see carefully. I am showing you a wonderful diagram. In that diagram, you can see carefully, you can observe carefully, there are two axes. Just see, this is the x axis, this is the y axis. On that x axis, here is a short circuit current, Is is given, short circuit current. When the short circuit occurs, when the arc length is 0, then what is the length at this point? 0. Yes, as we are going here, the length is going to increase. And now what is length at this point? When the length is maximum, then it is open circuit voltage, means length 0, length maximum, then first length is L1, minimum length is L1, L2 is little bit bigger, got it? Then what is L1? Just see, L1 we written that it is 2 millimeter, they given 0.2 centimeter, and L2 is 0.3 centimeter. From that we got that L1 and L2. Now see, very important, L1 is, when there is L1, just see at this point there is L1, at this point there is L2. When L1 is there, what about current I1? Just see, here the current value 0, this value is increasing, this value is increasing, this value is increasing. And you can see the higher is I1, lower current is I2. Now see here, which is I1 and I2. Higher current is I1, which is I1, higher is I1, 500 ampere, and I2 is lower, that is 300 ampere. Then how to give pair? Lower length and higher current. Why so? Lower length 0.2, higher current, higher length, lower current. This diagram you must keep in mind. Yes, this diagram you must keep in mind that, and you need to, this is I1, this is I2, and that concept which I told you, here the length is 0, here the length is maximum. If you know that concept now, you will never do mistake, it is my guarantee to you, right. Now see the next point. Yeah, this is one pair, this L2 I2 is one of the pair. Yeah, now we have to calculate here open circuit and short circuit current. Yes, students are solving. Yes, very nice response here. Now we will solve this question also. Yes, I am writing here for stable equilibrium condition, voltage in arc is equal to voltage in power source. What is voltage in arc? It is A plus B into L is equal to, what is voltage in power source? It is V open minus V open divided by Is into I. Yes. Now you tell me, is A plus BL? We know that yes, it is given in problem. You can see that it is a 20 plus 40L. This is guys A, this is guys B. Then it is 50 plus 20L is given in problem, and I am writing with the confidence 50 plus 20L is equal to, is V open given? Never, we need to calculate. Is a short circuit current given? No. I. Now you can see, you can observe clearly this L and this I. How many L you have? You have the two L, this L1, L2 you have. How many I you have? You have two I's, I1, I2, right? 2I is there. Now see how to solve here. Just see, I am writing here the case 1. I am writing here the case 1. How to solve in case 1? In the case 1, I am taking L1 and I1. What is L1 here? 0.2 centimeter. What is I1? 500 ampere. Just put that all the values in this wonderful equation. I am writing that value in the wonderful equation, that is 50 plus 20 instead of L1 0.2 is equal to V open minus V open divided by Is into of this I is I1. Yes, now see how I am solving. 20 into 0.2, that is 454. Then I am writing here V open minus V open divided by Is into 500 is equal to 54, and that is the wonderful equation is known as equation 1. Equation when we got. What you have to calculate? You have to calculate V open and short circuit current. Then only problem will finish. Yes. Now see equation 1. Now L1 I1 is over. Now case 1 is over. Now you have to see the case 2. For what purpose? Case 2 for L2 I2. L2 I2. Just see L2 I2. I am writing case 2. I am writing case 2. L2 is 0.3 centimeter. What is I2 is 300 ampere. Yes. Now what is our equation? 50 plus, just see our equation. 50 plus 20L. Yes, 20L. L2 we have to put, and here I2 we have to put. 20 into 0.3 is equal to V open minus V open divided by short circuit current into I2. I2 is 300. Yes, solve this. V open minus V open divided by Is into 300. What is the answer? 56. This is equation 2. This is equation 2. Yeah, we got both equation. My students is giving me answers. Yes, they are solving very fast. Very good. Try to solve very fast. Yes. Now see the two equation we got. Now how to solve that? I am writing here equation 2 minus equation 1. Yes, equation 2 V open divided by V open by Is into 300 is equal to 56. This is mathematics only. Yeah? V open minus V open by Is into 500 is equal to 54. Yes, equation 2 minus equation 1, this is 2, this is 1, this minus plus, yes, this minus, then you can get here V open by Is 500 minus 300, that is 200 is equal to, here is 2, then we got V open by Is is 2 by 200 means 1 by 100. I am writing here V open by Is, V open by Is is 1 by 100. Yes, this relation we got. Now we can put that relation anywhere. We can put it in equation 2 also or 1 also. I am putting in equation 2. Put V open by Is in equation 2. Yes. Now we can put V open minus V open by Is is 1 by 100. Into 300 is equal to 56. We can write here 3, then V open is 59. Don't forget unit, it is volt. V open is volt. Now we know that V open by Is, we got it is 1 by 100. Now solve it here. V open is 59 divided by Is is equal to 1 by 100. Then here we are getting the short circuit current, that is 5900 ampere. With this question is over. We got both the answer, V open and short circuit current. Yes, I want to see your replies. Very good, very nice replies, very good. Darshan Jadhav, Ashutosh Pradhan, Surya, Bittu Kumar. Really you are enjoying lecture. Yeah. Now the next problem is more important. Next question you can see the more and more important, very important while teaching welding. I always tell that. Now see how question this is. The power source in particular welding setup generate 8000 watt. What is power? You know that power is equal to VI, which is generating 8000 watt power. The cross sectional area of weld bead is 30 millimeter square. Cross sectional area of weld bead is 30 millimeter square. Just see such a type of question they are asking every year. Every year they are asking, every year. Then this is most important question. This is second question, third question and next one, fourth. I think total fourth question are there. Very important question. Don't go anywhere, attend this question. Yes, very important. And the travel speed, that is welding speed. Travel speed means what? Welding speed is given 8 millimeter per second. 8 millimeter per second. Yes. The heat required to melt the material is 12 joule per millimeter cube. Means they given the U. U is what? Heat required to melt the material is 12 joule per millimeter cube. When the joule per millimeter cube is given, then you can write that is U, joule per millimeter cube. With the melting factor is 55%. What is melting factor? That melting factor is also known as melting efficiency. You know that the melting efficiency, but most of the students don't know melting factor, and if the examination they are giving melting factor, then very badly they are losing their 2 marks. It is 55%. What percentage of the total heat produced by the arc is delivered to the weld? Something different. You are feeling something different here. What percentage of the total heat produced by arc is delivered to the weld? Students, this is a question on arc welding. This is question on arc welding. Yes, just see in the arc welding what is happening. You can see in this diagram. If the arc is developed here, some heat is developed. Some heat is developed. But whatever the heat developed, the total heat will not reach to the workpiece. There are some losses. There are some losses. There are which losses are there? From here you can see some losses are there, and that losses are convection losses are there, radiation losses are there. But that's why you can see whatever the heat produced at the arc, some heat loss in the convection and radiation, and only some heat will go here at the workpiece, and that efficiency is known as heat transfer efficiency. That efficiency is known as heat transfer efficiency, and that heat transfer efficiency you have to calculate. That heat transfer efficiency you have to calculate in this question. I am looking at your replies. Yes, some student already calculated. How brilliant, na? Darshan Jadhav, Sri Hari, Vinayak, already they calculated. How brilliant. And through from the starting of session the reply is constant, na? You are attending the lecture, you are taking interest here. Very nice. Very nice. Sunny, come on. Very nice. 65.45. Already the answer is given. Right? Really very nice performance, wonderful performance. Then I am writing here. Just see the two things are important. This is melting factor, is melting efficiency, and second what efficiency this is. That's why this is a confusing question, but you got that. This is heat transfer efficiency. Yes. Now see. Now I want to write the formula for melting efficiency. Heat required for melting. Heat required for melting. Just see the formula of melting efficiency. Heat required for melting divided by net heat supplied. Net heat supplied. Then melting efficiency, what the melting efficiency is given here, you can see that 55%, then I can write here 0.55. Heat required for melting, it is given by UAV, and this is net heat supplied, that is power. Net heat supplied, that is power, that is I am writing Vi into this efficiency. Which efficiency? Heat transfer efficiency, and that eta heat transfer efficiency we have to calculate. Then you can see that it is 0.55. What is U? What is U? Just see, U is 12. 12. What is area? 20. What is speed? 8. This eta we have to calculate. What is V? What is I? You can see V and I is not given. Just see, I written area wrong. Area is 30 and V is 8. That is right. V is 8. Yeah. Now Vi means power is given, and that is 8,000. 8,000. Now calculate this heat transfer efficiency, and already students got that answer, and that is 65.45. Yes, 65.45. This question is over. Now you need to give me here in the chat section whether you like this question or not. But I know that there are some difficulties. Actually, here I am feeling little bit bad. Why I am feeling bad? Because I like to explain here number of concepts, but it is not possible for me. That's why I am feeling very bad. But my student, I already explained such concept. Yes, here I am really, I want to explain, but I can't. But already I explained, my students are getting everything here, right? Now see. And other student also, you can message me on WhatsApp. Yeah, I will work for you. I like to help the students, right? Now see the next question here. We have less time here. We have less time today, but still our syllabus will over in that time. Yeah. Now this is wonderful question. Wonderful question. Now see what they given. Yes. An arc welding is performed with a voltage of 20 volt. Just write it fast. Voltage is 20 volt. And current of 175 ampere. Current is 175 ampere. Yes. That can be transferred to work surface. V and I, that is power. We are transferring to the work surface with the heat transfer factor is 0.7. What is the heat transfer factor? And that heat transfer factor is also known as heat transfer efficiency. Also known as heat transfer efficiency. What they given here? Heat transfer factor 0.7. Wording is changed. Yes. The metal to be welded is low carbon steel. Which metal we have to weld? Low carbon steel. Means there is a plate of low carbon steel whose melting point temperature is 1760. Different question, melting point temperature is given. What is that melting point temperature? 1760 Kelvin. The melting factor in the operation. Oh, melting efficiency is also given, is 0.5. 0.5. A continuous fillet weld is to be made with a cross section area is 20 millimeter square. Cross section area is 20 millimeter square. Determine the travel speed. Means we have to calculate the welding speed, and that welding speed is given by just say this V. What is that V? V is welding speed that we have to calculate here. Yes. Calculate determine the travel speed, welding speed at which a welding operation can be achieved, can be accomplished. K is a constant whose value is 3.33 into 10 raised to minus 6. Now see in this question, you may think that why this is given? Why this is given? Just wait for that. Try to solve this question. Yes, you will get that why that things are written, where we are lagging, and for that only they are given. Right. Now see. Yes. Now directly I am writing the formula of melting efficiency. Yeah, I have to write that formula of melting efficiency. Bas. Now the students are waiting and no one given answer. I know that this question is not easy. Huh? They are trying, they are thinking to solve this question. Heat required for welding divided by net heat supplied. Net heat supplied. This is the formula for melting efficiency. Melting efficiency is equal to heat required for welding, that is U, not mu. UAV divided by net heat supplied means what? Eta into V into I. Now put the all values. Now what is melting efficiency is given? You can see that melting efficiency is 0.5. What U is given? Joule per millimeter cube, na? U is joule per millimeter cube. Is a joule per millimeter cube is here? No, not given. That is worry for us. U into, we have to write the area and we have to calculate this V divided by this eta V into I, all the terms will write. What is A here? A is 20, V is also 20, I 175. Yes, and the heat transfer efficiency we have to see what they given, that is heat transfer efficiency is 70% they given, 70%. Yes, 0.7. Now we can't solve this question. We have to calculate the travelling speed, we have to calculate the welding speed, but we can't calculate because we don't know the value of U. Yes, no replies from here, just reply me. Huh? How are you feeling? Just reply me, I am waiting for your reply. Yes. How to calculate that U? U is equal to, just see we have one formula, K into Tm square. Then what is U? What is K? The value of K is given. Value of K is given. What is that K? 3.33 into 10 raised to minus 6. 3.33 into 10 raised to minus 6 into Tm, that is melting point temperature square. What is it is given? 1760 Kelvin. 1760 Kelvin. It must be in Kelvin. It must be in Kelvin. Yes. Then we can get the value of U, and that value of U, will be in joule per millimeter cube. Yes. Now tell me what is the value of U? Yeah, Darshan Jadhav, tough question, right. Yeah, you can reply me freely, yeah, we can discuss it here, we can speak it here. Yes. Now what is value of U? Give me answer, what is value of U? I think the value of U is 12. Then just calculate the value of, no 12, it is 10.31. Calculate and send me here values. I am waiting for your replies. It is 10.31 joule per millimeter cube. Then put the value of U here. We are getting the answer of V, and that answer of V is 5.93 millimeter per second. Yes. Very good. Yes, really. Very nice. And now last question we have to see here on the welding, which will be on resistance welding. There may be the one question on, means one question will be there, at least 2 mark, arc welding or resistance welding. First 3 questions we discussed about the arc welding. Now the 4th question, last question we have to discuss, which is on resistance welding. Still you solve and you give reply. Yes, now I am moving for next question. Yeah. Yes, question number 4. The unit melting energy for a certain sheet metal is 9.5 joule per millimeter cube. Unit melting energy. I am always, it is defining in terms of U. But when I solve the question on resistance welding, I don't like U. I like that U in arc welding only. In the resistance welding, I am writing for that HR per millimeter cube. Heat required per millimeter cube. What is HR? Heat required. What is heat required? Heat required is 9.5 joule per millimeter cube, means per unit volume. Per unit volume. This is the given. The thickness of each of the two sheet to be spot welded is 3.5 millimeter. Thickness is little bit bigger is given, right? 3.5 millimeter. To achieve required strength, it is desired to form a weld nugget, that is 5.5 millimeter in diameter and 5 millimeter in thick. Weld nugget dimensions are given. I am writing weld nugget dimension. I want to write on next page only. Just see weld nugget. What is the diameter? Is given 5.5. I want to see it once. 5.5 millimeter dia and 5 millimeter thickness. And thickness is 5 millimeter. Which nugget is there? Spherical or cylindrical? You can see the diameter and thickness, mean diameter and height is given. If the diameter is there, if the height is there, then it is cylindrical nugget. If only diameter is given, then it is a spherical nugget. Now calculate the volume of this nugget. Volume is pi by 4 d square h. Here I want to write d square t. Then we can calculate pi by 4 d square is 5.5 square into t is 5. Yes. Now see again what is given. Yeah. The weld duration will be set at 0.3 second. What given? That is welding time is given 0.3 second. If it is assumed that electrical resistance, just see which welding is there? Resistance welding is there. How you got that? Because resistance is given. Na? In the arc welding no resistance is there. Tell me what is resistance? Oppose to flow of current, that is known as resistance, and opposed to flow of current, that is resistance, is happening in only resistance welding. Hence you can think that, hence you can understand that this question is on electrical resistance, means resistance welding. The electrical resistance between the surface is 140 micro ohm. Yes, I want to write that resistance is 140 micro ohm. Then I am writing R is equal to 140, convert micro into ohm, 140 into 10 raised to minus 6 ohm. Right. And the only 1/3 of electrical energy is generated, and the only 1/3 of electrical energy generated will be used to form weld nugget. It is something different. Whatever the energy we are supplying, whatever the energy we are giving, after that only 1/3 means 33% of energy is going to utilize, is used for the welding. Then what is efficiency grade, guys? The efficiency is only 30%. Efficiency is only 30%, 33%. I want to write here 1/3. I want to write here 1/3. That is 33%. Yeah. See next. Determine the minimum current level required in this operation. How much current required in this operation, that we have to calculate. How easy? Just see all the given data here and solve this question. Yes. Now see what is the formula for efficiency. Heat required divided by heat generated. Heat required divided by heat generated. Yes, then this efficiency is given. What is the value? This 33%. 0.33 is given. What is heat required? How easy formula? You can make the formula. If you don't know how you can make HR per millimeter cube. What is HR? Heat required per millimeter cube into volume. HR per millimeter cube into volume divided by heat generated. What is heat generated? I square RT, very famous formula, I square R into tau, time. Now put that all the values, 0.33 is equal to what is heat required per millimeter cube. It is given in the question, just you can see it is 9.5. It is 9.5 into, you can see that what is the volume. Where I written that volume? Yes, here. Yes, this volume pi by 4 into 5.5 square into 5. This is the volume. Pi by 4 into 5.5 square into 5. Try to understand here, less space is there. You can see here, this volume same we have to put pi by 4 into 5.5 square into 5. This volume is there, no need to worry, divided by I square RT, I square, R is what? R is what? 140 into 10 raised to minus 6, 140 into 10 raised to minus 6 into what is time here? Into time is 0.3 second. Give me answer. Time is 0.3. Try to understand, less space is here. Then what is the answer of current? What happened? Something, student is writing the answer of I square by mistake. They forgot to do the square root. Yes, do the square root and give me answer. Yes. Yes, many students gave that answer. Really best performance. Mr. Kumar is saying that conceptual problem. Darshan Jadhav, Rajkesh, Surya, Bichu, Sunny, Sri Hari, Mushtaq, all are solving this question and the answer is 9023.45. 9023.45 ampere. This is current. Yes, this question is also over. But again, I want to tell you that these are the questions. Just see, the time is very minimum. I want to say you that please focus on the numericals. Please focus on the important part. Try to solve previous gate questions, previous gate numericals. And in the exam, you must be master in the units. If you are weak in units, you will fail in life. And if you are master in unit, you will enjoy the life. That is why units are very important. And in my lecture, I taught units. I give focus on the units, and that units can give you mark in every subject, and your future will be bright because of units. Yes, then do the study. If you want, just I am giving my phone number 9359 455 955. My name is Ravi Sir. I am teaching most of the chapter of production subject, that is manufacturing subject, at ACE Engineering Academy. You can contact me. This is my WhatsApp number, but please try to avoid call. Just put me message on WhatsApp. If you don't have WhatsApp, then you can send me simple text, right? I will reply you. If time permits, I will call you also. If you have any queries related to anything about your future, about technical problem, technical doubt, anything about my subject, you can contact me freely. Yeah. Now see, I want to tell you that which theory is important. Just see, the IIT Kharagpur like the theory of brazing, soldering. You see how the topic in welding, that is soldering, brazing and braze welding, that theory IIT Kharagpur like, as well as oxyacetylene gas welding also IIT Kharagpur like. Then just focus on that two theory topic. And in the numericals, there are only arc welding and resistance welding numericals. From that, out of 2, 1 numerical you will get in the examination. Yeah, I think that is enough. And now see the last. Yeah, now you can see, this is the offer from ACE Engineering Academy. 15% off is there. When there is off, when you are using the code RAVMP15. This is RAVMP15, this is my code. If you are using this code, then you will get 15% off on all ACE Online GATE and ESE courses. What is that ACE Online? Just go to Play Store. If you do not know, go to Play Store. You will get, there is an app, ACE Online, that is our app, and in that app you will get the recorded lectures. In English to English language also means full English. This lecture I delivered in English, and even though we can speak in Hindi also, that Hindi course is available there. Means everything is in English, only we are delivering that lecture in Hindi plus English communication. You will get in that Play Store app, then you can use that code, and that code is expiring only tomorrow at 6 p.m. that is 4th January, that is tomorrow this code is going to expire. Yes, and now I want to say you that thank you very much. May you take interest in my lecture, and from first to last minute the number of students are same. From the starting they started increasing, and what one point it was constant up to the last minute, and now again I want to say thank you very much and best of luck for your GATE 2022 examination. Thank you again, thank you very much.